Welcome to Power Math. Today we're going to be discussing polynomials. All right, now this term sounds real technical, but when you break it down, there really is not a lot to it. Okay, let's go through what this actually means. Okay, poly means many. Okay, multiple, more than one. Okay, then we have nomial, which means either names, or we could say like terms. Okay, if you wanted to get even less technical, I guess you shouldn't say it like that. If you want to get less technical, then we would just say things. Okay, so what we're dealing with is many things or multiple things. Okay, let's go through the list of different types of polynomials or nomials, and then let's talk about what we're going to do with them. Okay, so if we just have 2x, all right, that's what's called a monomial. Hopefully well, maybe you haven't, but if you've been on like a single rail unit, kind of like the thing at Disneyland, it's called the monorail, right? There's a mono, it's a single unit, right? We have one thing, okay? If we have this guy, 2x plus 4, now we're dealing with well, there's two parts. A bicycle has two parts, so therefore, I don't know if that's a good analogy or not, but we're going to go with it. We're going to call this a binomial, okay? Because there's two parts. And if we add a third part, kind of like that thing you learned to ride before the bicycle, okay? Don't yell out tricycle, come on. It's not a tricycle, all right? But if we have 2x squared plus 4x plus, we'll make it another number, 3. Sorry, that's ugly. Now we have three parts. So this thing is called a trinomial. Okay? And if we have four parts, it's called no, it's not called a quadrinomial, okay? Like everybody always makes that mistake. It's just called a polynomial because poly means many. Who knows how many there are, okay? So if you have anything after that, it's just called a polynomial, okay? I guess technically you could say that this guy is a polynomial because there's more than one part. You could say that this is a polynomial as well because there's three parts, all right? And so when we're working with polynomials, there's kind of a standard format that they need to be in, okay? And usually you'll hear this when teachers or books will say something like the leading coefficient, okay, which sounds real technical, okay? But what they're really trying to say is the thing with the most x's or the most of that variable has to kind of be in the front. And the reason is if we had this trinomial here, let's say I wrote it as 2x squared plus 3 plus 4x, and you said, oh, well, hey, I like to do it this way. I'm going to write it as 3 plus 4x plus 2x squared, okay? Notice how we have the same stuff, it's just in a different order. And people a long time ago decided, you know what, we're going to put them in order from the most of the exponent down to the least. And then from there, we'll go into numbers and other stuff. Because that way everything is very standard, it's very uniform, and for the most part it works. And as you're moving into Algebra 1 and other classes like that, you're going to want your stuff in order because it's just going to keep things nice and neat. So let me take this out of the way, and let me just give you something like 4x to the 5th plus 3x plus 7x squared plus 9x cubed plus 12, okay? So we have all these different things. Oh, let's add one more just because. We'll say let's see, we didn't use 5x to the 4th, okay? This is super big, right? This is all kinds of crazy stuff, but it all gets back to making sure you order your polynomials in the right way. And the right way to do it is to start with the biggest guy here, right? The biggest amount of that exponent, and then work your way down. So we would go 5, then 4, then 3, then 2, then 1, and then down to the numbers, okay? So I'm just going to rewrite it here. We have 4x to the 5th plus 5x to the 4th plus 9x to the third. And if it helps you when you're reordering polynomials to cross them out as you go, then go for it, right? That's just going to remind you what's left and what's here. Plus 7x squared plus 3x plus 12. Okay, so now what we've done is we've put them in descending order from the highest amount of exponents. And most teachers and stuff like that are going to want you to do that because what you're doing is you're putting them in order so that we can work through this in an efficient manner. Okay? So let me erase this guy. And I guess we could erase all this too. Okay, I'll leave that up there just because that's the topic of the lesson. But you might say, well, what if you're missing a couple parts? Like what if you have 4x cubed plus 2x plus 9? Okay, well, you know, what if there's nothing in the middle? What if there's no x squared? That's okay, right? You just put them in order like this. Let me give you another example where they're out of order. Let's say we have I'll just use parts of this. We'll say we have 9 plus 2x plus 8x to the fifth plus 4x to the third. Okay, so I used all these parts again. Let's see here. So if we were going to reorder this, we would use the one with the highest amount of that exponent and start with that guy. Okay, so the leading coefficient is going to be this guy. So we would start with 8x to the fifth plus 4x to the third plus 2x plus 9. So it's okay if you're missing a couple of the parts, right? You're only working with what you're given. This is just an expression, right? It's not an equation. We're not solving for anything yet. We're just reordering the polynomial so that we understand, we're showing that we understand the order that it should be in so that we can then work with it. Okay? When it comes to adding polynomials, we're going to be doing the same thing, all right, as we did with adding basic numbers. So if we have 2x squared plus 4 plus 6x squared, okay, we can combine like terms. Now there's a whole other power math lesson on combining like terms, but I just wanted to kind of roll into this just so you start to see, well, why am I going to need this? Why do I need to learn this stuff? I always like to kind of explain to students why you want to know it, so hopefully that helps you buy into what you're doing in class. For this problem, we would be combining like terms, okay? Now, this has an x squared and this guy has an x squared. So we can combine those two terms and make it 2x squareds plus 6x squareds is 8x squareds, okay? Plus 4, and then you're all done, okay? So this would be an example of solving an expression, right? That's not an equation, it's an expression because it's just a bunch of stuff that you're gonna kind of condense down or combine like terms. Thanks for watching.